Hi class, Mr. York here. Obviously we have a strange week this week, so I'm recording this video so that we can still get a little bit of learning in, and hopefully, even though we don't have a ton of class time together, we can still set the stage for the things that we're going to be learning next week and the week after. Alright, so I've set up this kind of strange camera mount so that hopefully you can see what I'm writing on my desk. Let's see if I can do this. There we are. Okay, so hopefully you can see my notebook here. And I'm going to zoom in just a little bit. Maybe a lot. That's all right. And I think before we get into something new, let's just very quickly run through what we already know. Three main terms we've learned so far this semester, and those are displacement, velocity, and acceleration. And I think you're pretty comfortable with all three of those. But just as a reminder, displacement is delta x or delta y. This will become increasingly important in the next couple of weeks. And generally we've been defining that as final position minus initial position. That's all. And I guess in practical terms, when we have something that moves, like here we go, here's a person, and they are moving to the right, their displacement will be wherever they ended up minus wherever they started. So, I don't know, if somebody walked 9 meters to the right, that would mean that their displacement is 9 meters. If they walked 9 meters to the left, that would mean that their displacement would be negative 9 meters. Velocity actually builds upon displacement, and our definition for that was v is equal to delta x divided by delta t. So change in position divided by change in time. And just like displacement, somebody's velocity can be either positive, so like if this person's moving to the right, they'd have a positive velocity, or it can be negative, depending on the direction it points. We also discussed a couple of scenarios in which something moves up or down, and we said that up generally in physics, there's a convention that says that's going to be counted as positive, and things pointing down are generally counted as negative. Acceleration is honestly the hardest to conceptualize because it's harder to see. You can see somebody moving to the right, and it's obvious that that person has a positive velocity, or you can see somebody moving to the left, and it's obvious that person has a negative velocity. But acceleration? It's more nuanced. You have to look at somebody. If you have, let's say we have two people moving to the right, these very strange people are both moving to the right. It's not just which direction that they're moving that determines their acceleration. It's how they're moving and how their velocity is changing. So if this person, let's say, started slowly and sped up as they moved, then that person would have a positive acceleration because they're speeding up to the right. If this person started out going fast and then slowed down, then we would say this person has a negative acceleration because they slowed down moving to the right. So it is a little bit more nuanced, but I think you guys have done a really good job of understanding acceleration and using it to solve problems. But all of these things have something in common. Displacement, velocity, and acceleration. In the way that we used them, they all had one thing in common, and that is that they were one-dimensional. which means that they all took place along a straight line. So it may have been something moving left and right on the x-axis, or it may have been something moving up and down on the y-axis. But things always kind of moved along a straight line. This next unit is different just in that we're adding a second axis, and we're going to be using both of them at the same time. So we'll be using the y-axis and the x-axis. That's kind of a sloppy x. But it's not more difficult. It's just there's slightly more things to keep track of. So while in the pencil, well, in the past we had vectors that only pointed, directly to the right or directly to the left or directly up or directly down. Now we'll have some vectors that point in between. Maybe this is a velocity vector. And it might seem impossible to work with at first, especially if you have a question that's like, if this is the velocity vector of an object, how far will it go along the x-axis in 10 seconds? Well, it's very hard to tell because this isn't pointing directly down the x-axis. But today, or right now in this video, I'm going to teach you a little trick that I think makes it much, much easier to think about these vectors that aren't pointing in a nice axial direction. Okay, but in order to do that, we need to talk a little bit about vectors. And I know you already know about vectors, but it doesn't hurt to review them. So obviously a vector, and you guys remember this, is something that has both a length and a direction. So, for example, this is a vector, and maybe let's say it's, I don't know, what is that, 5 centimeters? If it's 5 centimeters long, this isn't just telling me the length, it's also telling me it's 5 centimeters to the right. It's very important that each vector has a direction. It's not just a line, and that's why, some of you might remember me trying to coax you away from drawing displacement like this or something, because it's not just a length. It's a vector with a direction. We can also have, a vector like this, which is a completely different vector from this one, in that it's pointing to the left. This one would probably be negative value. But I think you're okay with this. The thing that I'm going to introduce now is probably brand new to you, and I really like it. And it's that you can use vectors to do arithmetic. You can actually add vectors together or subtract them or multiply them. There's a lot that you can actually do with vectors. And if you're a visual learner like me, it's actually kind of fun to draw them out and solve problems that way. So let's talk first about vector addition. Let's just do a little problem. Let's say we have two vectors, vector A and vector B, that we want to add together, and they're going to create another vector called vector C. That's going to be our answer, our result. So let me grab a colored pencil. Maybe let's use blue and red. So let's say vector A, it can be anything, but let's say vector A is just like this along the x-axis kinda, and vector B is like, let's say vector B is like this. We can add these together visually without really doing any math. We can just visually stick them together and create vector C, and I'll show you how to do that. Really all you do is take vector b and stick it on the end of vector a. We could actually do it the other way around too, because addition works that way. Like 1 plus 2 is the same as 2 plus 1. So we could change this to be b plus a instead of a plus b. It doesn't matter. But let's try it. So I'm going to take vector a and draw it here. I think it's, how long is it? 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. There's vector a. And then I'll take vector b and draw it here. How long is that? 1, 2, 3. Okay, so 1, 2, 3, like that. And I've done it. That's vector a plus vector b. And it's going to create a new vector that just goes from the beginning of a to the end of b. So our answer is going to look like this. I'll just draw it here. That's vector c, just like that. It's actually very simple. Again, all we did was take these two vectors and stick them together, stick the arrowhead of this one onto the tail of this one, and draw a vector from the beginning to the end of both. There's also vector subtraction, which is similarly pretty simple. I'll just write that here. And let's do a minus b. And it's going to create something different. So I'm not going to call it c. I'll just call this vector d. Doesn't really matter. And in vector subtraction, you take the one that you're subtracting from and just draw it normally. 1, 2, 3, 4, 5. There's vector a again. And now we need to add the opposite of vector b. And if vector b is like this, the opposite of it is going to look like, let's see, 1, 2, 3. It's going to look like this. So I'm going to take this and add it to vector a. So here we go, 1, 2, 3. There we are. That is a and b. So vector d is just going to be from the beginning to the end of both of them. So like that. And there we go. That is vector subtraction, vector addition, and vector subtraction. And this is where the trick comes in. It involves looking at vectors like this one. Let me just draw this out. As if it were the answer or the result of something like this. That might sound confusing, but I'll show you. I'll show you what I mean. So let's just quickly draw an axis here. Doesn't really matter. There we go. This is the x-axis. This is the y-axis. And let's say we have a vector that we'll just call it v and draw it out like this. Okay, now previously, this vector would have been really hard to work with, especially if we're trying to answer the same types of questions we've been answering, like how far would this go in the x direction after a certain number of seconds? Well, I don't know. It's not completely pointing in the x direction. It's pointing somewhere in the middle. Or if you asked, how high would this go in 2 seconds or something like that? I don't know. It's hard just looking at it. And the key to figuring out how to use this is to imagine that this is the result of combining two easier vectors. And as we know, the easiest type of vector is one that goes along an axis. So I'm just going to quickly draw what I think might be an easier vector that could have made this, or two easier vectors that could have made this. And I'll draw them here. I'll draw one like this. I don't know if you can really see that showing up here. One like that. And I'll draw another one like that. And what I've just done is I've created one vector that points in the x direction and one vector that points in the y direction. And together they both equal this one. So, and you know how to use these. So if I ask now how far would this object with this vector go in the x direction, now we can just use this vector here. We don't need to use this complicated one, we can just use this one. And if I asked you how high would it go in the y direction, well, you can just use this vector here to answer that question. So this process is just about taking something complicated and replacing it with two easier things. This process, this thing that I just did, I hope it's somewhat clear to you that x plus y here is equal to v with the vector addition that we learned just now. This process is going to be super important, not just for this next unit, but for many units down the road, because there's something special that it does. Doing this creates a right triangle. I'm sure you can see it here. Maybe if I draw the little box in like that, it's a bit easier to see. This is a right triangle. So if we know the length of this and the angle here, I'll just draw theta. If we know the length and the angle, then we can find these two sides easy. You guys have taken geometry, I think. And we just use a tiny bit of trigonometry in order to find other sides. So even if we only know this side, and we're trying to find this, well, you remember the Pythagorean theorem. This side squared plus this side squared is equal to this hypotenuse squared. We're not really going to go into detail right now about how to do this. Some of you, I'm sure, looking at this already have an idea of what you could do. But I just wanted to put it in your mind now, because maybe later this week and also next week, we are going to start using this and trying to figure out how to use this technique to solve problems. It's a very important technique that I honestly used throughout high school, college, and even graduate school. It's something that is really good to have in your back pocket as a physicist. So I'm gonna leave us here. I know we haven't really shown how to use this stuff, but I'm just giving you a taste now because this is a weird week. I hope you guys, I hope this video was okay, not too long. And I hope you guys have a great day, and I will see you back in class. Bye, everyone.